Hello, everyone. Looks like some people are still joining. Give 1 second, maybe.
Yeah, maybe we will wait 1 or 2 minutes. I guess we can start. Hello, everyone. Welcome to our session. Today, we will introduce you to the topic DevOps for machine learning and also have tools, processes, and tools for the ML lifecycle, but by Kenny Daniel.
Thank you. Yeah, really glad to be here and presenting virtually for ODSC. So just to start off with a little bit about just who I am and kind of, what my relevance to the industry and things here is. So I started off in academia. I have degrees from CMU and USC. I was doing my PhD in AI and machine learning, starting back in 2006 before it was cool. And even after that, I've worked in industry as a practitioner, building and deploying computer vision models for startups. And then more recently, I'm one of the 2 co-founders of Algorithmia, which is a platform for productionization and scaling and management of AI and machine learning models. So I've kind of seen a lot of different sides of the industry. And in this talk, I want to talk about DevOps and machine learning and some of the lessons there. So I want to start off by having everyone in the audience think a little bit about if you were to be starting a project today, whether it's just a weekend project that you're hacking on or founding a company around a new product or just building a new feature or something within a larger enterprise. There's this question that naturally comes up of how do I actually deploy this model? And it's often not something that's thought about until fairly later in the process of machine learning. And there's many approaches out there, but there's not a clear obvious choice, in my opinion. If you talk to 10 people, you get 10 different answers about how they actually deploy their machine learning models in production. And so this talk is going to be going over some of that, my thoughts on that and some of the lessons I think that we could learn from more traditional software engineering about how to attack this problem. So the first thing to understand is that machine learning is not the same thing as production machine learning. As I said, I've been an academic, I've been in industry, and I've been also on the infrastructure side of things. And a lot of the work that's being done in machine learning, it's not ready to be put into production. It's not ready to be hooked up to 1 million deployed iOS apps sending images. It's not ready to be part of a backend data pipeline that is handling terabytes of data per day. And there's a huge number of ML projects that fail to make it out of the lab, whether academic or within a company, specifically because they fail to reach production. So the number of reasons for this, some of which are unique to machine learning, but I would argue that a huge problem is that our industry has failed to learn the lessons of software engineering and DevOps and modern DevOps that have been developed over the last several decades. So in traditional software engineering, when I say traditional software engineering, I mean, building APIs, websites, still modern software, but, not machine learning. There's this idea of the software development lifecycle, so SDLC. And that's just recognizing the fact that it's not just about, the code that you write, it's about the tools and the environment and the infrastructure that you build up around it. So I think that personally, I think that the machine learning industry has a lot to learn from more traditional software engineering. There's been 20 plus years of software development, and the industry has matured so much in terms of best practices and tools and infrastructure. So just as, a kind of anecdote story of, where this failure is coming into the world of machine learning, I was doing my PhD in machine learning, and, over the course of years, not once was mentioned Git or source control. I ended up using it personally because I kind of had that software development mindset. But this is actually like a pretty widespread thing. Is that it's not the first thing that comes to mind in machine learning, and we still go talk to Fortune 500 companies. I won't name names, but they have data scientists that are doing, they're building models in their laptop in Jupyter Notebook, and they're not source controlling their things. They're iterating, they're playing with parameters, they're playing with network architectures. And if you ask them to go back, hey, what was the one you tried a couple days ago? They might not actually be able to even do it because it's not getting checked into source control. Now that's not universal, and things are definitely getting better in that regard. But that's just the most basic thing. There's so much more beyond source control that has been built up over the years. So the image didn't quite come out exactly the way I wanted there, but so what does the software development cycle look like? There's some things here which will hopefully be familiar to just about everybody that are largely table stakes. If you were developing a traditional software product, you would use Git for source control. You would have a CI system so that when you git push, that triggers building of the code, running tests, potentially even going out and deploying this code. Continuous delivery. So that's having infrastructure and systems that you can go from the CI straight into delivery so that you can test things and call things automatically and without developer intervention. And then finally, there's all the things that fall under the umbrella of management. So that's logging, that's alerting, that's observability, that's being able to chart and graph and visualize what's actually going on in your system. So I would argue that there are analogies for all of these things in the machine learning world. So source control, maybe it's the same thing. I think you could still use Git. I think that's something that's maybe not still fully appreciated, as I was saying. So, I think there's room for that. Continuous integration, what would that look like in the world of machine learning? That can be running tests, that can be running, evaluations, that can be doing things like performance testing and load testing. Continuous distribution, there's the question I started off with here, which was, how do you deploy this model? What infrastructure and what tools do you use? And the fact of the matter is that a lot of the tools that you would use to deploy traditional APIs and services are not going to be as amenable to machine learning for a number of reasons, not the least of which is specialized hardware requirements, things like GPUs. Also, the runtime characteristics can be very different, where you might have a very, very long cold start time where you have to load a multi-gigabyte model file into GPU memory before you can even start performing operations. So all of these things impact how you'd want to build a deployment platform for machine learning. And then finally, management, there's a lot of similarities, but there's also some sort of characteristically unique things in the machine learning world that you might want to think about with manage. We'll talk about that a bit more later in the talk. So it's not a perfect analogy. And I don't want to act or pretend that machine learning is no different than traditional software, because it is. So in traditional software, your code is your output as a developer. In machine learning, the inference made on your code is based on the data and that you train on and the code that you write. So while traditional software development is focused on pushing out new builds, machine learning depends on basically two things, both the code and the data. So that impacts what this cycle is going to look like. And additionally, machine learning is very much about this loop that you see here. Traditional software is as well, but with machine learning, it's even more true that you want to close this feedback loop, because if your machine learning pipeline is just a line, just moving straight from data to training to inference, you're missing out on a huge amount of the power. And the benefit of this is being able to feed back in updated labels or feedback in where things have done better or worse on your model and be able to improve it over time. In a certain sense, that's the core of DevOps and traditional software too, is being able to iterate and move forward quickly. Along those lines, this idea is not new. This was observed back in the 1950s even with Boyds' law of iteration. And what that is that the speed of iteration beats quality of iteration. So this is something that this is a theme that you'll see echoed throughout many disciplines. Boyd, who's the law was named after, was actually studying, he was a general studying aircraft dogfighting. So nothing to do with software, still recognized the same thing, that iteration is more important than quality or initial quality. Sports has recognized the same thing. Sports training recognizes the same thing, that the time to iteration has a huge impact on how rapidly you can learn things. Software engineering, certainly. This is kind of the core of agile development. And so in a certain sense, I like to ask the question of, well, what would that look like if you tried to apply agile development principles, not the dogmatic, just, not the process as much as just that idea of, you want to be able to iterate and close that feedback loop and make it, do that as quickly as possible. And then finally, software testing is all about failing early and often. And so these are all lessons that have been, hard learned over years of doing software development and other disciplines. So let's break down the phases of the ML lifecycle. I apologize, this graphic didn't come out quite as well on the screen with the low resolution, but the main categories are data. First, the first step of any ML project is figuring out what your data is, figuring out how you're going to connect to it, and what you have available, or if you need to gather it and label it. There's the training step, which is going to be followed by deployment and management. So we'll start diving in deeper on each of these phases of the ML lifecycle. So there's a lot to be said about data, but it's a bit out of scope of this talk. There's plenty of people talking about that at this conference, and it's obviously relevant, but I really want to focus on kind of what happens after that. So you need to be able to connect to your data sources, and any system, any production system that you're working with has to be able to do those things. That's table stakes, because data is useless without algorithms. That's kind of been the lesson also of Hadoop and the big data era. All these companies hoarded data, built up these massive warehouses of all the data that they could, and until you actually start digging through that and making sense of it, it's not doing anything. Now, conversely, I would argue the same, is that if you have an algorithm but you don't have data, it's probably just equally useless. So we really need to marry those two together. So after you've got the data, you want to start talking about training. So again, I'm not going to focus too much on that in this talk, because it's very different fundamentally to do training than production. Training is, the initial training, certainly, it's a very interactive exploratory process. So it's typically going to be a data scientist. Maybe they're working in a Jupyter notebook, they're experimenting, they're tweaking the parameters, they're trying different network architectures, they're doing feature engineering. It's very interactive. It's not scaled horizontally. It's in a certain way of looking at it, it's very stateful, as opposed to stateless things, which can just be scaled horizontally. It's typically a one-time or rare or intermittent event that you're doing this training. It's very long-running time. It's an intense amount of compute, and it's a relatively fixed inelastic load. And it's also almost always going to be a single user who's performing these experiments. So this is very different than the sort of traditional production scenario where you're trying to take a piece of software and scale it horizontally. You're trying to replicate it thousands and thousands of times to be able to handle whatever traffic may come. And so that's why I want to distinguish between the training phase and the tools and solutions for that versus the deployment phase and the tools and solutions for that situation. But I do think that there's absolutely relevance of DevOps to the training phase as well. And as I was saying about, there's companies out there that absolutely need to have accountability for how their models were developed and trained, not only what code generated it, but what data generated it, things like that. So I'd absolutely think that there should be a much stronger push to use source control and things like that in our industry. But it's also kind of interesting to think about, well, what's different about machine learning? Well, there's rather than just one code base. In a certain sense, with every model, there's two code bases. There's the actual code that runs and does the training, and there's the code that actually does the serving and the inference. And in virtually any situation, you need both of those. Even in situations where you're using things like Onyx and packaged up model files, you're probably going to need some code. Maybe it's just boilerplate code, but some code to manipulate the input and get that into the structure that the model expects, take the output of the model and do that. So I've been advocating for having a to-Git solution to this, which is have a Git repo for your training and a Git repo for the actual inference code and the model execution. So this allows you to track individually, how is the training done, how is this generated, and then also how is it going to be running. Furthermore, so thinking back to the training thing, one of the lessons of DevOps was, the more you can automate these things, the better it's going to be for developers. So don't make developers, run tests on their local console before they push. Make it so that when you push, the tests are run automatically in winters and all that. And not making users leave their existing workflow. Any kind of interruption like that is going to be a big impediment to productivity and being able to iterate and move as fast as possible as a developer. So if you're a data scientist and you're, say, in a Jupyter notebook, as you see, one of the things which I think is really exciting seeing coming out of the industry is basically being able to do deployment directly from a notebook. So this is an example with Algorithmia of how we can do it with just a couple lines of code at the bottom of the Jupyter notebook. You go up at the top, you build your model, you experiment, you try things. And when you're done, basically just execute the notebook from top to bottom. And that last step will take your model that gets trained and it'll push it up, make it available and ready to go as a REST endpoint that you can call, you can test, you can do whatever you want. Similarly, you can do the same kind of thing actually if you're using a to-Git system. If you push your notebook up, you could actually build a CI system using something like, say, GitHub Actions or Jenkins or whatever your tool of choice is to take that notebook, execute it, build the model, and then with some boilerplate at the end of the notebook, just push that up to your deployment. So you can actually increase security in your machine learning platform if you do it this way, because now you can also separate privileges where you as a data scientist don't actually technically need to be able to push code up to production. All you need to be able to do is push source code and push a notebook up to a Git repository, and then the whole CI system takes over from there. It can give you assurance as a company that, hey, this code that got pushed up is exactly the code that generated this model. Whereas if a data scientist builds the model on their laptop, even if they push the code up to the source code up, if they're taking that model file and they're just delivering it as a binary, there's a threat model there, which is that you're not actually 100% sure that code generated that model. And that leaves open opportunities for mistakes, first of all, where, hey, I uploaded the wrong model file and it didn't do what we wanted, or malicious things too, which is where, you could have a malicious actor uploading a binary model. If you're not sure of the code that generated that could potentially be a problem depending on the company and the industry. So ML deployment does have some unique challenges, to be sure. After you've gotten past that training phase, you want to deploy it. Why not just use something like Heroku or an ECS or any one of the Elastic, whatever? And the answer is that there's some unique requirements with that. Not the least of which is GPUs. So people like to think, so taking a step back. So Docker has revolutionized how deployment is done. By and large, people aren't deploying VMs anymore. People want to containerize things and then push them out, and so that you can more efficiently utilize resources. It just solves so many problems. But when you start talking about machine learning, it doesn't quite work as cleanly as one. People treat Docker containers in many ways like they're very lightweight, fast virtual machines, but they're not. The fact of the matter is if you have one machine and it's running 10 Docker containers, all those 10 Docker containers are sharing the same kernel. And so that abstraction of Docker as this lightweight VM starts to break down, because anytime you're touching something in the kernel, that boundary is not so clear. And so there's been a number of systems out there that have been built up to try to solve this problem. And but it's still early days, to be sure. Also GPUs are not super amenable to multi-user systems. They don't really have memory limits. They don't really have memory boundaries. I've given a whole other talk actually just about some of the challenges involved with that. You can probably find it online. But basically, how do you handle that when you can't actually guarantee a boundary? And the short answer is you kind of have to make a best effort of saying, historically this model has used X amount of GPU memory or X or Y amount of resources, and just essentially hope that it's going to continue using the same amount going forward. Now, this is generally a reasonable assumption, but it definitely adds to the challenges of building a deployment system for machine learning. Furthermore, there's all sorts, it's very heterogeneous tools, and they're evolving very, very quickly. And everything needs to match up, especially in this Docker world, because again, some of it lives outside of the Docker container. So there's CUDA, there's the NVIDIA drivers themselves, there's the Python version that you're running, there's scikit-learn, there's TensorFlow versus PyTorch versus all that. And a lot of systems that I've seen start to become opinionated about which tools and frameworks they support and which they want your machine learning and data scientists to use. And I think that's often a mistake, especially in a field that's evolving as quickly as it is. Just a year or two ago, everything was TensorFlow, and now you look at the numbers, and PyTorch is the more used one in papers being published, and rapidly ramping up in actual use in industry. So I think it would be naive to think that we figured out what are the tools going forward. And I think if you tie the hands of your data scientists to a particular tool, you're limiting what your potential is with machine learning. So that's deployment. How about management? So management encompasses a number of different things, and this is largely the domain of DevOps, as I was talking about. Measuring model performance, testing, accuracy. We'll talk a bit about monitoring and alerting and things like that. So let's talk about testing and measuring model performance. So, as I said, this talk is largely trying to draw an analogy between traditional software and machine learning. What is testing? How is it different in the machine learning world? Well, it's generally not saying, pass, fail, does this code work or not, the way that traditional unit tests and such work. It's often more about, an accuracy score, or, there's different measurements of that. There's the sensitivity, the recall, the F1 scores, the things like that. There's all these different ways you can do it. It's multidimensional. And it's, as I said, not typically pass fail. So I think that there's a lot of room in the industry for people to invent, new ways of testing and new systems for doing this that make more sense in the world of machine learning. And this is something that I see as lacking very much in our community right now. Where are the tests? Almost every model, gets a base accuracy score because that's critical for training. But there's much more to it. What would a unit test look like in the world of machine learning? I think it's really interesting to ask. Maybe in the world of machine learning, a unit test isn't about one piece of functionality testing whether it works. Maybe it's about testing that one slice of your input domain still produces good results. So what I'm getting at with that is, maybe I'm building a model to recognize faces or whatever it is. And, great, I get 90% accuracy on the overall data set. But if it doesn't do well on subsets of that data set, maybe it doesn't perform well on women or minorities or whatever it is, that could be a problem. And that starts to look like a unit test to me. So I would love to see more of that in our industry, where we're not just looking at the top line number accuracy, but we're also kind of looking at individual subsets of the data or individual parts of the model to make sure that, especially as we update it over time, that we're not getting regressions, that we're not getting worse performance on some aspects, even as that top line number starts to get better and better. So there's some other things that are fairly unique to machine learning that I think also merit mentioning in terms of testing. there's different types of drift. This is something that people are very conscious of. There's model drift, there's concept drift, whether you're updating the model and evolving it, or whether maybe just your underlying data set changes out from under you as you're going. So, classic example of model drift. I build a fashion detector to recognize clothing on people, shirts, shorts, etc. Trained it on data in the summer, and it's working great. It's 90+% accuracy. Then you get to winter, and all of a sudden, outfits are not the same. Fundamentally, the domain of your inputs has changed, and so now your model doesn't work anymore. And if you're only running tests when you push the model, it would be very easy to completely miss this. So in a certain sense, unlike traditional software, you might need to run tests more often on a regular cadence, where you might not expect your web server to break if the code ran successfully 6 months ago, but in machine learning, it's not quite so guaranteed. So, as I was saying, it's not just about testing, and this is also kind of one of the lessons that's been learned over the years, is that there's a lot more that goes into management and DevOps and building a system that developers can be at their maximum productivity and that services have maximum reliability, performance, and can be part of the larger ecosystem that a service, modern services goes into. And so that means logging, that means monitoring, which I think also has kind of some unique connotations in the world of machine learning, as we were saying. Alerting, and again, that might not just be, hey, we got an error, or hey, like the accuracy has plummeted. It could just be, the domain of the data has changed, or confidence is lower, on the output of the model. So there's a lot of things there which I think have not been fully appreciated. And I think as we see machine learning continue to advance, we're going to see more and more of these kind of industrial production tools applied to the world of machine learning. So, okay, we talked about, some of the things which I think could be doing better in the world of machine learning. Why aren't we seeing more of those things? Why aren't we seeing CI and CD for machine learning? Why aren't we seeing more monitoring and alerting and things like that? Well, I would assert that there's a couple things that go into it. First of all, wrong teams and wrong personas is one of them. So I think a trap that companies can often fall into is asking data scientists to build and deploy the models that they're building. And there's certainly appeal to that, they're the ones writing the code and all that, but it is a very fundamentally different data set or skill set. And as I was saying, I went through most of a PhD program and didn't even have Git mentioned. Like, they certainly didn't teach best practices on deployment and scaling and reliability. It's an entire job in and of itself. Its entire career. So I think that allowing people to specialize makes a ton of sense. But people have realized this in traditional software as well, that a front-end developer versus a back-end developer versus a DevOps engineer, they specialize, and they spend years and years and decades of their life, mastering their thing. There's no reason to ask them to do something which is outside of that wheelhouse, or you can do better if you allow people to specialize. So recognizing those personas are that there's the data scientist, there's the DevOps engineer, there's the business value that's also critical, because if you're just building machine learning in a lab or isolated, and it's not driving towards business value, that's going to be a problem, and that's going to be a big problem for our industry if we don't, as data scientists and machine learning engineers, recognize that that's how we're going to be judged, and that right now is a really good time to be a machine learning or AI engineer. But if we want to avoid having another winter or a decline, we have to show that there's real value to this, and there is. I fully believe when you see use cases where you get the right data and the right algorithm paired with the right use case, it's really, really powerful. But that's what we really need to focus on is what is each of our responsibility in that process. So, other challenges that kind of we're facing, preventing some of this. It's a very young field, and it's growing very, very fast. And so I think that part of it is just a lag where some of this stuff will catch up. But it's also just it's different in other ways, where it's not the traditional software engineering team. There is a bit more sort of pure exploration and almost academic searching, but you need to unify those worlds. So there's a really good paper out there that Google put out. Highly recommend checking out if you want more information on this, but it talks about kind of what are the challenges of deploying machine learning systems, and why are companies failing and why are projects failing today. So some more of the challenges. There's generally, there's a lack of understanding. There's a lack of process. There's a lack of the right systems in place to get these things there. And people recognize that if you're deploying a website or if you're deploying a web app, whatever it is, there's going to be X infrastructure costs. You're going to need to pay your monthly pager duty bill, your monthly this, your monthly that. And as much money and all has flowed into the machine learning industry, I don't know that corporations and enterprises have figured out exactly where they need to be spending the money in order to get the results that they're obviously hoping to get with machine learning. The lack of process, this has also been hard won in sort of traditional software and recognizing the importance of DevOps. But I think that recognizing that there needs to be more process, and not everybody loves process, and sometimes process can slow down work, but good process, properly sized and appropriate process makes life better as a developer, not worse. It makes it so that you can focus on your job, write the code that you need to write, do the explorations you need to do, push that off, and let automated systems handle as much of that as possible from there. And then lack of proper champions. You need to go outside of just the machine learning department. You need to be talking to the customers, the business, the business people who are determining what's going to be the value of this. You can't be operating in isolation. And so should that be the data scientist, or should that be someone else? I don't know, but that, I think it's something that if you don't think about that at some level, as an organization, you're just going to default to what is we have today, which is not a somewhat I think that there's roadblocks that don't need to be there. And then there's other challenges of using the wrong technology. It's fairly it's not uncommon. I've seen where people, as I said, almost every company has a way of deploying services. Every company has a way of deploying, a website and things like that, or containers even. They at this point, lots and lots of companies either have a Kubernetes install, or they're using ECS or whatever the equivalents are. And so they say, well, okay, we're trying to deploy some machine learning. Well, it's all the same, right? We can just deploy it like regular software. But that's not often the case for many of the reasons that I was saying. But also, as I was saying, that if you're too opinionated about this technology, you're going to increase friction. You're going to limit, what can be done. And ultimately, there's been a lot of sort of monoliths built of, I'm trying to avoid naming names here, but there's a lot of sort of infrastructure and big names out there that are fairly opinionated about what tools and things you use, and they try to be the be-all, end-all solution from start to finish of machine learning. And I just don't think that's the way things are headed. Again, if you look at sort of the traditional software development, there hasn't been a move towards all-in-one solutions. If you want to deploy a website or a web app, what's the all-in-one solution? They do exist, but that's not what's won out in the industry. People want to choose the best tool for the job, and the more valuable and the more critical to a business a project is, the more you're going to want to fine-tune and swap out individual pieces and have the best CI system and the best source management system and the best alerting and logging and monitoring and all these things. And that's rarely going to be the case that the end-to-end solution is the one that has the best of all those components. So maintaining that flexibility and allowing users to choose and companies to choose the best technology for the job is really critical. There's also some challenges that are specific to the enterprise. So there's infrastructure agnostic deployment. People talk about not avoiding lock-in. And look, realistically, do people migrate from one cloud to another just because a better deal came along or something? Like, no. But especially if you're in a, a big enterprise, sometimes you might acquire a company and some technology comes in that way, or you might be in the process of a migration from a lot of existing on-prem architecture to moving towards the cloud, and you want to have consistency on your machine learning platform in the cloud or on-prem or in multiple clouds, because ultimately machine learning, it's critical that you go to where the data is. And so, not getting locked in can be really critical there. At least for maintaining consistency across your organization. Similarly, there's all sorts of additional requirements of authentication and compliance and regulation and governance and security and all that comes into play when you're talking about enterprise. And ML also has to kind of figure out what are some of the unique challenges there. How do you deal with data that needs to be accountable, but is also subject to these regulations, things like in the EU, right to be forgotten. Well, what if you trained a model on some data and now you're legally required to have purged some of the data that was used to build that model? How do you handle that? You kind of lose some reproducibility there. So I think that there's definitely opportunities for people to step in and figure these things out, and as an industry for us to get more mature along that line. So, as just kind of some sort of final advice, navigating common pitfalls that I see and that we, at Algorithmia see a lot in industry as we're building this. Don't try to reinvent the wheel. I think this tweet kind of perfectly captures that. Big companies should avoid building their own machine learning infrastructure because every tech company I talk to is building their own custom machine learning stack and has a team that's way too excited to be doing so. And I get it. Look, it's fun. It's fun to build these systems, and it's interesting, and it's a greenfield like new thing. But unless you are a massive company at the scale of Google or Uber or things like that, it's probably not a great use of your resources to be building your own new machine learning deployment framework. There's a whole bunch of really exciting things, being built in the industry to kind of try to solve these problems. Avoid lock-in, as we were talking about. Perfect is the enemy of the good. Iteration is key in that regard. It's better to start with something. I'm not saying, don't build any machine learning until you've figured out your whole machine learning lifecycle. It's much better to get started, get your first model deployed, because many companies haven't even gotten that far. They might have a team of data scientists, but haven't gotten a single model in production. We see that all the time. So definitely, get something out there and then improve over time. Iterate, iterate, iterate. Speed of iteration beats quality of iteration all the time. Audit honestly, revise constantly. So finally, just to reiterate, machine learning is not the same as production machine learning. And as much as this is a greenfield space in machine learning and nobody knows where it's going to head or what tools are going to be dominant a year from now, it's not. We don't have to invent everything from scratch. We can take inspiration from the discipline of software engineering. There's entire institutes dedicated to this. There's all sorts of thought leadership along this line. And I think that if we take a broader look outside of just our field and see what are some of these best practices and tools and things that have made life better for developers, that we can make our lives better as machine learning developers and as companies trying to leverage these tools. So that's that. Hopefully with this talk, I've given some things to think about, really. What are some of the challenges? What are some of the things which we're not really thinking of as an industry? And maybe that will inspire some people to go out and build some solutions to these things to really push the industry forward. Just final kind of shout out, I run, as I said, founder of Algorithmia. We do a lot of this stuff. Production machine learning is what we do. And so if you have any questions or if we can be help or even just want to chat about something, please don't hesitate to reach out. Thanks.
Thank you, Kenny. It was a pleasure having you today. Thanks to all of attendees. I see we have questions. Is there a place we can download the slides? So it's mandatory. If Kenny share with us slides, the slides will be available at our platform with the recorded talk.
Yeah, absolutely. I probably haven't made those available to ODSC yet, but I absolutely will. So if you can't find them on the website, don't hesitate to reach out to the email up there, or however you want to reach out, and I'll get you a copy of the slides.
Thank you so much, and don't forget to rate the session and enjoy the rest of the day. Thank you.
Thank you.